Hello everyone. This is our lecture number 9 of module 2 and today's topic is Cauchy root test. Cauchy root test. Okay. Again same question. How to understand that we have to apply Cauchy root test. Remember here the nth term, that is un will be in some power of n. Okay, that means the power of un will be a function of n. For example, suppose un to the power n square, un to the power, let's say anything, n to the power 5. The power will be some variable of n. Okay, in that case we can use Cauchy root test. So let's write the statement. Let summation n equals to 1 to infinity un be a positive term series. Okay, such that limit n tends to infinity un to the power 1 by n, this is equals to L, and that must be finite number. Okay, limit n tends to infinity un to the power 1 by n, this is equals to L. Now if L is less than 1, then summation un is convergent. If L is greater than 1, then summation un is divergent. Okay, and number 3, if L is equals to 1, test fails. Clear? So first step is you have to find out un, then calculate un to the power 1 by n and the limit of un to the power 1 by n, and if the limit is some finite number, then you will get these three results. If L is less than 1, summation un will be convergent. If L is greater than 1, the series will be divergent, and if L is equals to 1, then you can claim that Cauchy root test fails. Let's solve a problem. Test the series summation n equals to 1 to infinity n by n plus 1 whole to the power n square. Okay, solution. Here un equals to, obviously this is in standard form, so n by n plus 1 whole to the power n square. I have told you, if un is in some power of n, or you can say if the power of un is a variable of n, natural number n, then you can use Cauchy root test. So obviously here power is n square, so obviously we can use Cauchy root test. So limit n tends to infinity un to the power 1 by n, this is equals to limit n tends to infinity un to the power 1 by n, that means n by n plus 1 whole to the power n square, this is un, and power of un is 1 by n. So this is equals to limit n tends to infinity, this n square and 1 by n, this will be multiplied, na? So this will be n by n plus 1 whole to the power n, because you have a formula that a to the power m whole to the power n, then m and n will be multiplied, so this is equals to a to the power m into n. That's why n square into 1 by n, so this will be n. Okay, now if I divide by n, so this will be limit n tends to infinity 1 by 1 plus 1 by n whole to the power n. In my last lecture I have told you the formula. Limit n tends to infinity 1 plus 1 by n whole to the power n. Same sign, so the result will be e. So this is equals to 1 by e. And 1 by e less than 1 or greater than 1? Obviously less than 1, because the value of e is between 2 and 3. So denominator is greater than numerator. So this is less than 1. And according to Cauchy root test, if the limit is less than 1, so summation un is convergent. Clear? Summation un is convergent. Let's solve another problem. Examine the nature of the series of the series 2 square divided by 1 square minus 2 by 1 whole to the power minus 1 plus 3 cube divided by 2 cube minus 3 by 2 whole to the power minus 2 plus 4 to the power 4 divided by 3 to the power 4 minus 4 by 3 whole to the power minus 3 plus dot dot dot. First calculate un. What will be un? So un equals to, starting from the first, n equals to 1. Here you can see 2 square by 1 square. When n equals to 1, 2 square by 1 square. n equals to 2, 3 cube by 2 cube. Yes or no? N equals to 3, 4 to the power 4 by 3 to the power 4. So what will be n equals to n? So first 2 square. So that means this is 2 square, 3 cube, 4 to the power 4. So that means this is of the form n plus 1 whole to the power n plus 1. Yes or no? And the denominator is 1 square, 2 cube, 3 cube, etc. That means n to the power n plus 1. Okay. Now you can check, put n equals to 1, n equals to 2, n equals to 3. You have to verify it. Okay, this is hit and trial method. Minus. For n equals to 1, this is 2 by 1. N equals to 2, this is 3 by 2. N equals to 3, this is 4 by 3. Okay, so when n equals to 1, the numerator is increased by 1. So for n equals to n, numerator will be n plus 1 and denominator will be n whole to the power. For n equals to 1, power is minus 1. N equals to 2, power is minus 2. N equals to 3, power is minus 3. So n equals to n, power will be minus n. Okay. So obviously here the power is variable of n. So you can use Cauchy root test. So limit n tends to infinity un to the power 1 by n. This is equals to limit n tends to infinity n plus 1 by n whole to the power n plus 1 minus n plus 1 divided by n, okay, whole to the power minus n into 1 by n. Okay, so this is equals to limit n tends to infinity. Okay, if I divide by n, so this will be 1 plus 1 by n whole to the power n plus 1 minus, and this will be 1 plus 1 by n, and power n cancel, so this will be minus 1. Okay, now this is equals to limit n tends to infinity. Okay, 1 plus 1 by n whole to the power n plus 1. So obviously we can write 1 plus 1 by n into 1 plus 1 by n whole to the power n minus 1 plus 1 by n whole to the power minus 1. Now limit n tends to infinity. This will be 1 plus 0. Okay, and this is 1 plus 1 by n whole to the power n. So this will be e na, e. minus, this is 1 plus 0 whole to the power minus 1. So what we are getting? From here you are getting e, and from here you are getting minus 1 whole to the power minus 1. So this is equals to 1 by e minus 1. Now question is 1 by e minus 1, this is less than 1 or greater than 1? Let's understand. We know the value of e is between 2 and 3. 2 less than e less than 3. So we have to make this form 1 by e minus 1. Okay, so let's subtract 1. So this will be 2 minus 1 less than e minus 1 less than 3 minus 1. So this implies 1 less than e minus 1 less than 2. Now inverse. So this is equals to 1 greater than 1 by e minus 1 greater than half. So obviously from this expression we are getting that 1 by e minus 1, this is less than 1. So obviously this will be less than 1. And by Cauchy root test, if this limit is less than 1, so the series will be by Cauchy, the series is convergent. Okay, now try yourself, solve all the textbook problems. Okay, and Cauchy root test is very simple. Actually total series is very simple, just you have to find out the un. Okay, if you can find out the un, then the remaining process is very simple, and this is the main important part in total series chapter. Just you have to find out un. Okay, thank you so much.